Once again, good morning and welcome to our general mathematics class. Today we'll have lesson 3.10 and it's about solving problems on logarithmic equations and inequalities. Now let's start with today's memory verse, and it's found in Malachi 3 verse 10. It's very common to most of us, especially doing stewardship emphasis. It says, "Bring the full tithe into the storehouse, that there may be food in my house, and thereby put me to the test, says the Lord of hosts, if I will not open the windows of heaven for you and pour down for you a blessing until there is no more need." Let me share with you my paraphrase on that text. And if I'll paraphrase the whole text, here's how I will do it. Be faithful in returning God's share, and He will bless you exponentially. Again, be faithful in returning God's share, and He will bless you exponentially. If we remember the applications of logarithmic functions during the first lesson, in lesson 3.6, we have talked about the magnitude of the earthquake, the decibels of the sounds, and also the pH level. And your MVCA boosters is related to that. It's caring for our ears. By the way, tomorrow I'll be grading all the MVCA boosters, the remaining ones. So be sure to answer them. It's about caring for our ears. Some people have very good hearing skills, sorry, that they can hear sounds at negative 15 decibels. If a sound reaches 85 decibels or stronger, it can cause permanent damage to hearing. What sounds are good to hear? So you name what sounds are good to hear. Name 3. Then check the equivalent decibels. Like if you're fond of using your earphones, how many decibels can you contribute? If you're fond of hearing the drums or the bangs and the fireworks, how many decibels? And what sounds are harmful to the ears? Name also 3 and tell us about their equivalent decibels. And the last question, how can we take good care of our ears? Let's have the meta targets. At the end of this lesson, you'll be able to solve problems involving logarithmic functions, equations, and inequalities. Here's our venture activity today. It's about the pH. We commonly call it pH, but its full name is power of hydrogen. The pH level is categorized into 3. I told you last time, if it's 7, it's neutral. It's more than 7, it's basic. If it's, or for other of your classes, you call it alkaline. If it's less than 7, it is acidic. And you check of sample pH conditions. Pure water is at pH 7. What's acidic? Human urine, tomato juice, and other gastric juices. If it's more what's alkaline, you have the human blood, hand soap, and household bleach. Now, and you can still read more on that, especially in your chemistry classes. Now let's start with solving our problems. We have 6 problems for today. Give me a moment, please. Okay, the first problem. What is the magnitude in the Richter scale of an earthquake that released 10 to the power of 14 joules of energy? Now, since we're talking about the magnitude of earthquake, then we need to have the formula for the Richter scale. Remember the formula? That is R equals 2/3 log E over 10 to the power of 4.4t. There. The next one. Remember what's the given? 10 to the power of 14 is our energy. And we're looking for the magnitude, the R. So let's substitute E to the equation. We have 10 to the power of 14 over 10 to the power of 4.4. Using your calculators, the answer will be 6.4. Therefore, the magnitude of the earthquake that released 10 to the power of 14 joules of energy is 6.4. Questions? Feel free to raise your hand, okay? The next one. The 2013 earthquake in Bohol and Cebu had a magnitude. This time, our given is the magnitude, the R. How much energy, we're looking for the E, was released by the earthquake? So let's have our formula first. That is R equals 2/3 log E over 10 to the power of 4.4. Remember, our R is given. That is 7.2 equals 2/3 log E over 10 to the power of 4.4. What's missing is the E, and the E is our anti-logarithm. So we need to solve this last. What do we do first? You check the number before the logarithmic sign. That's 2/3. So to make 2/3 equivalent to 1, we need to multiply both sides by its reciprocal, 3/2, and the other side by 3/2, so that this will be canceled. It will become 1. So our right-hand side will only have log E over 10 to the power of 4.4. The other side, you multiply 3 by 7.2, then divide it by 2. The answer is 10.8. Now, once you have your whole number on one side and your logarithmic expression on the other side, then we can eliminate the logarithmic sign by having them both in base 10. So 10 and 10. What will happen to the exponent? Give me a moment, please. I need to pause for a moment. I just need to listen to the announcements, okay? Now, you need to write both in base 10. What will happen to your previous numbers? This will turn into exponents. So we have 10 to the power of 10.8, and the other is 10 to the power of log E over 10 to the power of 4.4. Remember that if we don't have any base in the logarithmic expression, it means that the base is 10. So we can cancel this out. In the left-hand side, it remains 10 to the power of 10.8, while the right-hand side will just leave you with the remaining exponents, E over 10 to the power of 4.4. We'll do cross multiplication over 1, cross multiply them, and these two also. So 1 times E is E, and this 2, that's 10 to the power of 10.8 times 10 to the power of 4.4. There are two possible answers. Same base, you add the exponents. That becomes 10 to the power of 15.2, or another way is using your calculator, you'll have the answer of 15.2, or we say 15.2 joules. Any questions? Okay, now let's go to the next one. Problem number 3. In problem number 3, we determine the pH of a solution that has an H plus concentration of 7.42 times 10 to the negative 3 moles per liter. Since we have the problem on pH, then we need to have the formula for pH. Remember it? That's pH equals negative log of H plus. This one, the 7.45, is our H plus, our hydrogen ion concentration. So we now have negative log of 7.45 times 10 to the power of 3. Or this is move 3 steps to the right. That's 0.00745. So using our calculators, the answer is 2.13. The pH is 2.13 and it's considered acidic. Any questions? Or hope you have your calculators with you and you have started checking if it's correct. The next one. This time, we need to identify our H plus concentration. So still using the pH formula, equals negative log of H plus. Now we need to identify our H plus concentration of a solution with a pH of 5.71. So our pH is 5.71 equals negative log of H plus. Now, we need to eliminate the negative sign on both sides. So we need to divide both sides by negative 1. So we not only have log H plus equals negative 5.71. Now, there are two ways to do this. And the first way is having them both in base 10, right? Base 10, so we have negative 5.71 equals log H plus. We cancel 10 and log, so we now have 10 to the power of negative 5.71 equals H plus. So the answer will be 1.95 times 10 to the negative 6 moles per liter. But here's also another way. Like example, let me start from here. That's negative 5.71 equals log H plus. H plus is called our anti-logarithm. So how do we solve for the anti-logarithm? We can have the inverse of log negative 5.71. Now, how will you do inverse of log in your calculators? Here. Hope you can see it there. You see the log? Instead of having the log, you need to press shift log. Give me a moment first. I'll find for, next time I'll show you a calculator on screen. Okay, so example. Wait. Para makita ninyo. Okay. Ginapil niya sa black. This one, shift log. So, press shift log. Once I press shift log, here's how I do it. Then, write negative 5.71. Negative 5.71. That one. Then, enter. Here's the answer. Just in 2 decimal places, that's 1.95 times 10 to the power of negative 6. Any questions? Now the next one. Let's go to the 5th problem. Suppose you have seats to a concert featuring your favorite musical artist. Calculate the approximate decibel level associated if a typical concert sound intensity is 10 to the negative 2 watts per square meters. Now, since you have decibels, then remember the formula for decibels. That's going to be D equals 10 log times I over 10 to the power of negative 12. Let's solve for the right-hand side because this is our intensity. So we have 10 log of intensity is 10 to the power of negative 2 over 10 to the power of negative 12. Using your calculators, the answer for the decibel will be 100 dB. It means 100 decibels. So you imagine it's very loud. That's 100 decibels. The next problem, the last problem. Using the formula for compound interest, A equals P times 1 plus R over N to the power of NT. How many years will it take an investment to double if the interest rate per annum is 2.5%? So remember, P is our principal. And if you want a double investment, it means your A will turn into 2P. Why 2P? P is your original investment. And if you want to double it, it becomes 2P. If you want to triple it, it should be 3P. You want to make it 5 times, that's 5P. So it means 2 times of the original. The interest rate is 2.5%. That's 0.025. That is our R. Interest rate per annum. That's per year. So our N will only be 1. We are looking for the how many years? We're looking for T. So let's now start writing our formula. Next, let's substitute our given details. Our A will be double. It's going to be 2P. It's P times 1 plus our R is 0.025. Our N is 1 to the power of 1 times T. I'll work on the right-hand side first. It's going to be P times 1.025 to the power of T equals 2P. We divide both sides by P to eliminate this and the other one. So we now have 2 equals 1.025 to the power of T. To solve this, we need to make both sides into logarithmic functions. Now, what's the difference? In the previous one, you're solving for the anti-logarithm. So you need to have both in base 10, right? But we have the logarithmic expression. In this problem, there's no logarithmic expression, but we are solving for an exponent. So how do we solve for the exponent? Write both sides in logarithmic expression. Since we have both sides in logarithmic expression, we will expand it. Remember, this is an exponent, so it will go first. T log of 1.025 equals log 2. To only have t as the remaining number, we need to divide both sides by its corresponding, its companion's logarithmic expression. So log 1.025. Divide both sides by log 1.025. Cancel it. We only have t on one side. The other side, you use a calculator to solve. And the answer will be 28.07 years. So we say that we need to have 28 years or 28.07 years before the investment will be doubled. Any questions before I'll end today's discussion?